Suppose the monthly charges for cell phone plans are normally distributed with the mean mu equal to 75 and a deviation, a standard deviation of $21. Draw a normal curve with the parameters listed. Okay. So the normal curve has inflection points uh, at mu minus sigma, so the mean minus the standard deviation, and the mean plus the standard deviation. So they give us the mean and standard deviation. So we can start to flush this curve out by adding 21 to 75 and subtract 20 from 75, and it gives us these 2 points here, 96 and 54. Okay, we can repeat this and get an even smoother curve. Then he asks us to shade the region. For any normal distribution curve, the area underneath the curve to the left of the value shows the proportion of the cell phone players that cost less than that value. So for the shaded here region, it's less than $54. And shaded to the right will be some values that are more than that. So to shade the region that costs less than 54, you would shade this region here. These are all the possibilities for less than 54. Suppose the area under the normal curve to the left of x equals 54 is, they give us the area here. What does that mean if the area underneath the curve is 0.1587? Suppose that an area, the random area x is normally distributed with mean deviation. The area underneath the curve represents the probability that a randomly selected individual from the population will have the characteristic described by the interval of value. So in this case, the characteristic that is described by the interval values is the cell phone plans that cost less than $54 per month. So it's like a 15%, rounded 16% probability. So they'll have that characteristic of being less than $54.